Alright, welcome to the second module in the polynomial series. The first module we've discussed the definition and evaluation of polynomial. In this particular module, we are going to discuss the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by, say, x minus a, the quotient is a polynomial g of x of 1 degree less than the degree of f of x, with a remainder r still to be divided by x minus a. That's what remainder theorem states. Now, what we are saying is that f of x divided by x minus a is equals to g of x plus r over x minus a. If you look at this very well, if you cross multiply out by f of x is equals g of x minus a plus r. Now, if our x equals a, then we have that f of a equals g of a into a minus a plus r. This implies that f of a is equals to g of a into 0 plus r. Now, it then means that f of a equals r. So the remainder theorem is saying that to determine the remainder of a polynomial, we can simply substitute the point into the polynomial. In other words, what we did in evaluating the polynomials in our lesson 1, the previous lesson, was actually determining the remainder. What we did was we determined the remainder. Alright, having said this, let us take some examples to drive home the point. Now, if we are given to evaluate x cubed plus 3x squared minus 13x minus 10 divided by x minus 3. To get the remainder, one way to do it is to have f of x as f of equals 3 cubed plus 3 into 3 square minus 13 into 3 minus 10. And this equals 27 plus 27 minus 39 minus 10. And if you evaluate this, you find out that this is 54 minus 49, and that equals 5. So the remainder, f of 3, is 5. So in this case now we know that the remainder in this polynomial equals 5. That's the end. Let's take another example. Very quickly, we have 5x3 minus 4x squared minus 3x plus 6, all divided by x minus 2. Now, of course, f of 2, because of this, we are divided by 2. Remember, this is equated to 0, then we have 2. Now, f of 2 now is equals to 5 into 2 cubed minus 4 into 2 square minus 3 into 2 plus 6. So, from here, we have 5 into 8 minus 4 into 4 minus 3 into 2 plus 6. This guy is 40. This guy is minus 16. This guy is minus 6 plus 6. This 6 can take out this 6, so we have that 40 minus 16, and that's 24. So this is 24. So the remainder in this particular polynomial is 24. So take this third one as exercise. Evaluate. Okay, let me clean the board first. Now evaluate 4x 3 minus 3x squared plus 5x minus 3, all divided by x minus 4. So if you evaluate it correctly, your answer should be equals 225. So it should be equals 225. Okay, that's one way to arrive at the remainder. Now there's another way to arrive at the same solution. Let's look at it. It's a very popular one. It is called the long division method. Now using long division method, you can arrive at the same answer. Now let's start. X minus 3, that's our expression s cubed plus 3s squared minus 13x minus 10. Please pay careful attention to this method. It's very easy. Now what we do is that we look for a term such that when we multiply this first term, this term here, with the term, it will give us this. I say that again. We look for a term such that when we multiply this term with the term, it will give us this guy. Now, in this case now, the term is s squared. S squared. And remember from the definition of remainder theorem, we said the quotient is going to be a polynomial of 1 degree less than the given polynomial. So our polynomial here is of degree 3, and our quotient will be of degree 2. So that's 1 degree less than the polynomial. Now x times s squared will give us s cubed Minus 3 times s squared will give us minus 3s squared. This, of course, s cubed minus s cubed will be 0. So 3s squared minus 3s squared will give 6s squared minus 13x minus 10. So we'll repeat the same thing. We look for a term such that when we multiply this term with that term, it will give us this. In this case now is plus 6x. So x times 6x will give us 6s squared minus 3 times 6s will give us minus 18x. So we repeat our this thing. 6s squared minus 6s squared is 0. 13x minus 18x is equals minus 13x plus 18, and that is 5x minus 10. We repeat it again. This time around we have plus 5. X times 5 will give us 5x. And minus 3 times 5 will give us minus 15. Now 5x minus 5x is 0. Minus 10 minus 15 is 10 minus 15. And 10 minus 10 plus 15. So this is 5 here. Alright, if you look very well here, there's nothing that you can multiply with x to give you 5 except you go into fractions, and we don't do that here. So you find out that while we substituted directly, our remainder was 5. So in this long division method also, our remainder is 5. So this is another way to determine the remainder. Let's take another example to further strengthen your hold in this method. Second example, we have 5s cubed minus 4s squared minus 3x plus 6, and this is x minus 2. So going by the same method, you look for a term such that when you multiply that term with this term here, it will give you this term here. So in this case now I have 5s squared. So 5s squared times s will give me 5s cubed minus 2 times 5s squared is minus 10s squared. So that minus 4s squared minus 10s squared will give me 6s squared. I have minus 3x. I just bring that down because no term below, plus 6. I'll repeat the same process. This time around I have plus 6x. X times 6x will give me 6s squared. Minus 2 times 6s will give me minus 12x. So this minus this is 0. This 9x plus 6. So it will be the same method. Here you have 9 now. So x times 9 is 9x. Minus 2 times 9 is minus 18. This minus this is 0. 6 minus 18 is 24. Just as we got before. So this is another way to solve the remainder theorem, to find the remainder. So the third example that I gave you as exercise the other time, also use that to determine the remainder. Also, in addition to that, I want you to find the remainder of the following on your own. I'll give you their answers so that you can check after working. Okay, this is your exercise. Find the remainder of 1 3 minus 2x squared minus 3x plus 5 divided by x minus 5. Answer equals 65. 2x cubed plus 3x squared minus x plus 4 divided by x plus 2. Answer equals 2. 3x cubed minus 11x squared plus 10x minus 12 divided by x minus 3. Answer equals 0. So, with that, we have come to the conclusion of this second module. We have been able to establish what the remainder theorem is and the two methods we can use to arrive at the remainder of a polynomial expression. Now, having completed this, I need you to try those exercises out. So, please help us to reach other people, help us to help others by subscribing to this channel, clicking the notification bell for further notification on new. Thank you very much. See you in the next module.